When you're working on programs and environments, accessibility is really important for many reasons. And it's not just that we want to be able to deal with users with specific needs. That's obviously incredibly important. But also, I've discovered that whenever I put effort building a system and making it simpler for children, or simpler for people who don't program, or making it accessible for those perhaps who are blind or low sight, all the effort I put into there has multiple benefits, right? And we're going to see one right now, because can you read that code? No, it's not light enough. But luckily, I work with accessibility experts in the Netherlands, and I now have AAA-rated color theme, right? So you can actually, it works when you have low light. Works really well. Yeah, that's great. But hello. I've been interrupted. Hold on, yes.
People on Zoom cannot hear you.
People on Zoom can't hear me.
No, because...
Do I have to stay there?
So you have to stay there and talk to your computer? I'm so sorry.
Oh, I can't. I don't like standing in one place. Sorry, Zoom people. Sorry, Zoom people. I have to stand in one place now, and this is going to hinder this. Oh, I like walking around. There's a stage here. I can't take the microphone and move it now. Okay, right, I got to reset. I'm really sorry. Let's start again. So accessibility is important for many reasons. We'll go into that in a moment. But I'd like to talk to you about this system I built called Sonic Pi. I'd like to talk to you why I think it's interesting for you specifically, and also why it's actually interesting going forwards for the Elixir community in general, because I've got a lot of things to talk about. And I'm really pleased that there's like half of the audience have never heard of Sonic Pi, because I get to really talk to you about what it is and the challenges I've faced and why I built it. So I'm going to go really quickly through the history of Sonic Pi, why it was created, for what responses, how it's evolved, and where it's going to go. And at any point, please throw questions at me. I'm super happy to answer them at any point along the journey. And what we've done here is we've just jumped straight into the app. And the app was designed, it was built originally for the Raspberry Pi computer 10 years ago. I was working at the University of Cambridge, and I was working on weird, esoteric music systems that combined code and music, right, which is essentially what this is. But I was working on something different. Now, hopefully, the Zoom audience can see my screen. And if I go to overtone, I can't even type, overtone.github.io. So this is the system I was originally working on with a friend called Jeff Rose. And this is an environment based on Clojure, which combined the Clojure programming language with this amazing thing called the SuperClider audio synthesis engine. And that's kind of like Nginx or Apache, but for music rather than websites, which obviously is way cooler, right? Nginx just serves you HTML and whatever it is, assets you want to have. Whereas the SuperClider server, it basically speaks sound cards and works out how to talk to the sound cards, multi-platform across all the sound cards. But it also embeds in these things. So Euro rack modules. Has anyone seen these things? Like if the thing will work. Images. So this is like relying on Google for your slides. Hopefully there's pictures of like crazy, yeah, we are, lots of these synthesizers. Each of these things, each of these small boxes, they do some cool lighting effects. Look at that one, that's pretty cool. But each of these units, now I'm going to pause talking and point at something, then come back and talk, right? Each of those small boxes is about 200 euros. So these things rack up in price. But what's interesting about them is they all generate audio or manipulate audio in some interesting way, and you can plug them all together in new topologies to make new kinds of sounds and synthesis engines. Now, Sonic Pi, the SuperClider is essentially a software version of these Eurorack modules. So anything you can do with these Eurorack modules, you can pretty much do in SuperClider, and more as well, because you're obviously limited to how much money you've got to be able to buy, unless you're like deadmau5 and you can afford a massive studio as big as this room full of them. Most people can afford maybe 2 or 3 at best. So which 2 or 3 are you going to buy? Whereas SuperClider, you can have as many as your memory, essentially, can put into memory, which is very small. And then the real cost is CPU to execute these. They're little C programs, essentially, which are connected by a graph internally within the SuperClider engine, and it knows how to connect them so that the output of one goes into the input of the other. But these things are complicated, they're expensive. This thing, which I built, is cheap because it's free, it's open source, but also complicated. When I built it, I didn't think about trying to build something simple. That wasn't the goal. The goal was, I'm a programmer, we're all programmers, right? What's the most powerful thing we can build? That's going to be a fun thing to build. And so this was my imagination of this. And it's pretty powerful. But we heard earlier, actually, when Jose was talking about types. Well, he talked about the elephant in the room and being types. But I've got a different elephant, which I'll talk about later. The elephant in the room with types, what was interesting there is that Jose talked about, sort of alluded to the fact that people rarely talk about the length of time it takes to program something in a particular environment or context. So you'll always hear people warring about language X is better than language Y, right? And I'm here with my Ruby hat on, in front of Elixir programmers, and I'm not afraid at all, right? You can talk to me however you want, because really it's not about language X versus language Y, ultimately. But even if it is, it's not just about what features language X has over language Y, or how you can prove the things are more provable, or the efficiency. Those are all interesting sort of dimensions to talk about and to reason about. But what I rarely hear is, it took me 10 seconds to build this, whereas it took you a year. Right? If you're a business and you're building a whole thing around it and you've got a year to spend on that thing and you care about its performance and you care about the fact that it works really well, then fine, put your energy and time into a system and tools where it can give you those properties, and you put the time into that. But sometimes you've only got 10 seconds to write your program. Now you might joke or think like, what's he talking about? But literally, the environments I program in, nightclubs, you've only got 10 seconds to program your program. Because after 10 seconds, people are bored. Right? If it crashes and you want to get it started again, you've got 10 seconds. Well, people are like, what are you waiting for? Right? So you don't have a minute. You don't have 2 minutes or 10 minutes or a day or a week. You have 10 seconds. And so I think it's interesting to start to consider what kinds of programs you might write in 10 seconds. Now, you might think, well, this is not me. I'm not going to program in nightclubs. Well, I hope you do, for starters. Also hope your children do as well. Even if they don't, like in their school assemblies, that's a lot of fun. I've been to some really cool schools where they've done some amazing performances with the system I'm going to show you. That's fun. But you all use the terminal, right? You type ls, enter, that's a program. Right? And you know that in an environment where you've got a very fast feedback cycle between thinking of a program, writing the program, 10 seconds, you can do a lot of stuff. Obviously, you can't do everything you can do with a fully blown programming language typically, but you don't care about doing all the things. You just care about doing the small things you can do quickly. And so I think it's interesting to start to broaden the scope of the small things you can do quickly. So Adam Lancaster earlier talked about using LiveBook to do interesting interrogation of air ticketing systems. And I'm assuming the main motivation there is it's much faster to get from an idea to a result. And that's a similar kind of deal. And when I was writing this system, I did not consider this. It wasn't an interest to me. I was just, what is the most powerful system I could build? I essentially built a really cool set of tools for building things, but to build a new kind of sound or a new piece of music was a huge amount of effort. Now, that wasn't so bad for me. I was prepared to put that effort in. But what I soon discovered is I was giving these performances and giving talks, especially with the Clojure community. I remember going to a Clojure conference and giving this talk, and everyone was like super excited. And then they all started downloading it in the hotel rooms. And I remember walking back to my room and hearing all these noises coming out of people's rooms, right? They're obviously like messing around with overtone. But they never got past that. And that was an issue for me, because I was actually interested in seeing if I could try and have an impact on how people make music. And if all they're going to do is make weird sounds, that's going to... The music concrete people in academia might find that interesting. But the challenge I'm trying to ask, and it's got to this point more recently since I started focusing on Sonic Pi, is figuring out the question, how do we attract, how do we engage with a much broader, much more diverse set of people than basically clones of me? And that's an interesting question. And asking, I remember working in schools, and people in the UK were trying to ask the question, how do we write some schemes of work to get kids into coding? And so they asked old guys with beards, what did you like when you were a child? What got you excited? And they're, oh, yeah, sorting algorithms. Okay, well, that's a good one. Yeah? And no joke, right? So there was actually a scheme of work which was created right early on called Have Fun with Sorting, right? Give binary a try was one of them as well. It's like some kind of once you've tried binary, that's it, you're stuck, right? So I was interested to ask the question, how do we actually reach out to a broader set of audience? And also, it's a broader question is, how do you find a way to get that audience to care, you know, like about what you're doing? And I'm also interested in finding ways to motivate children to learn to code. And I think that when you talk about motivational figures, you say, you need to learn to code because you could become the next Bill Gates. That's exciting. Who wants to become the next Bill Gates? Oh, none of you. So why are you coding? Surely. Isn't that the goal for everybody? Steve Jobs. You want to be the next Steve Jobs? No? No. So I want to be the next Jimi Hendrix. That seems much more exciting to me. And I think that kind of whoever the Jimi Hendrix of the children is really going to be the motivational figure. So we'll get to talk about that at the moment. But this system, fun. If you like Clojure, it's a really cool tool to play with to generate audio. But it had no conception, no idea, no design about making things simple. It was just about raw, fun programming power. And you can do a ton of stuff with this, but it's quite laborious. And you've basically got all the bits to build a car. You can build whatever kind of car you want. Although, actually, I should talk about bikes. I don't drive. You can build whatever kind of bike you want. You can do all the bits, but you've got to do it yourself, and it's slow. And whilst I was working on this, the Raspberry Pi span out to the University of Cambridge. My funding was coming to an end on the things I was working on, and a small budget for 3 months to build a piece of software which might engage kids came around, and I was like, oh, I think I might be able to take ideas from this and port it to the Raspberry Pi. And so that's what I did. And of course, what's interesting there is a few things. One is that the Clojure stuff really got me into functional programming, and I really was interested in that and Lisps and things. And you'll see, actually, a whole lot of the design of Sonic Pi, if you look inside the source code, is really weird, right? I used to be a professional Ruby programmer. Then I really got deep into Clojure. And then the Ruby I wrote after that is the weirdest Ruby you'll ever see. But a lot of that was to deal with, like, I got some really cool tools in Clojure. Like, Clojure has a really nice concurrency semantics and has a really nice thing called a promise, a Clojure promise. And that's a really nice sort of box. You can put a value in later, and you can look at it later. And this was a really a tool I used all the time when I was building this kind of thing. And that's the kind of thing I ported into Ruby. So I sort of built the bits of Clojure I liked in Ruby to be able to work and to build the things I wanted. And so the question was, how do you build something for kids? I was given a 3-month project. In that 3 months, it turned out what the scope of the project wasn't just to build something that possibly might engage kids, which seemed quite ambitious, right? Like, I don't know anything about kids. Don't know anything about really kids software in schools. I last went to school like 20, 30 years ago. I don't know anything about this. So that's already a challenge. But in the first meeting, they wanted me to do that and find a teacher and work with a teacher to teach this thing in the classroom and design a scheme of work to teach the new introductory computer science curriculum with all this. So you can imagine that scope was ridiculous in 3 months, and evaluate it. And so I built the smallest thing I could possibly build, and it looked a bit like, oh, hello there, that's me. And we're advancing. It looked a bit like this, right? This is the simplest thing I could build. And this is like a Qt app, and it's just a simple editor. You type in some Ruby code, and it evaluates it, sends it to a Ruby server over the local network, and then the Ruby server prints out standard out and standard error. And so there's a pane over here, which is the standard out, and there's a pane over here for standard error. So it's kind of like mapped onto the Unix process, and it worked really well and got me going. And I was able to focus on simplicity. So to work with the schools, I made it as simple as I can. So this kind of like system here, you can see that I'm going to repeat this 10 times. So I've got some nice repetition. I've got a simple call to play, which makes a beep, and to sleep for some amount of time, and you can see what's going on. And so this is how it started. And those 3 months went really, really quickly. And I found a teacher, Carrie-Anne Philbin, and we worked together. It was fab. It was like one of the best experiences I had in a very long time. And because we sort of worked in a very iterative process. So I built the first version of Sonic Pi took 2 weeks to build. It was the simplest thing I could possibly build that made some results. And that was the only bit, really, that was like academic ivory tower work. The rest was all, and continues to be, in response to working with professional end users or whatever capacity. So in that point, it was with teachers in school situations. So I would build this thing, I look at the curriculum and say, we've got iteration, let's do that. So I think I can teach that. So I built something that supported iteration. We would teach it, and then after the lesson, we would sit down for an hour and discuss what we were going to do the next week. Then I'd go home, I would build the next version of Sonic Pi, take it into the schools on loads of little SD cards, plug it in, and teach the next lesson. And it went on for like 7 weeks. And the amount of time I took like burning SD cards I really dreamed of those machines, where you could like plug 20 SD cards in at once. And that was my, I really wanted one of those, but I didn't have that. So that was what I was working on, and it turned out to be really successful, and people liked it, the schools liked it, and the Raspberry Pi Foundation liked it, and they continued to fund me, and everything was going really well. And I then, I ported it to, that's Joe, I'll talk about him in a second. I ported it to the Mac, because I wanted to try and broaden the participation and the use. So here actually is the latest version, and you can see here, like, I just write the word play in 70, I can get a note, right? So it's like the first program people write. It's very blurry, so let's make that bigger. Wow, focus on this is, maybe if I move the code down, does it get more focus down there? Not really. Okay, so this is your first program, and you can then like sleep for a second and play note 75, and this is all cool. That's great, isn't it? That's amazing. But the complexity behind this to make this work is pretty exciting, actually, and I could talk about that for hours, and I don't think I have hours. In fact, I don't even know how long I'm supposed to be talking for. When do I finish, by the way? So it goes like 1/2 or something? So this was the original thing, and we could teach basic computer science with that, and that was fun. But actually, I really quickly ran into some interesting problems. And they were mostly not technical, actually. They were mostly political and social, particularly when you're working in schools. So trying to find ways to get around these barriers was really hard. And one of the barriers was, like kids would write, like, this was a fun thing I added pretty early on, was to be able to, like, do samples. So I wanted to play, like, a kick drum. Wow, that's super distorted. That's amazing. Look at that. Oh, that's horrible. So the best place I've ever run this code was a cinema in the Netherlands, in Ada, where there's, like, a beautiful, like, massive subwoofer system for Star Wars. And this sounds amazing on that, like that, but okay. And so the kids would write this, and they would write like a loop, and sleep for 1 second, and that's not fast enough. Let's make it a bit faster. Sleep for 1/2 second. There we're going, right? Okay, cool. And that's nice. So let's comment this out. And they would write another loop, and in this loop, Ned, and they would write, I don't know, let's do a little longer sample. Let's do like the loop arm end break. And, oh, I can't type. Arm end. And let's beat stretch that to 2 beats and sleep for 2 seconds. There we are. Cool. Let's make that a bit louder. Right. So the kids would write this, and then maybe they would have another thing they wanted to add. So they'd be working on these independently, and let's another one. Let's like loop, and let's do like sample, E, guitar, E. Let's go for that one. Oh, I'm working on a beta version, and the down arrow is not working properly. And then let's see for 4 like this. So something like this, right? And obviously, and the cool thing with the kids is that, and this is the most exciting thing for me, really, was that at the time, and still actually predominantly, most computer science lessons are what I call cookie cutter lessons, where the lesson is very, very, very carefully predetermined. And it's like, hey kids, we're going to do computer science today, and we're all going to end up with the same thing, right? And we're going to learn how to do that. And that's okay if all the kids want to do that same thing, which of course they don't. Everyone's different. Everyone's got their own ideas of what's interesting and what's not. And the nice thing about this is that I've written some live loops here, and the kids would write their own, and they'll be very different, and they'll be theirs. And that's one of the nice things about working with children, is seeing the creativity that they can produce. But anyway, so here's it. Oh, this is very loud, but this is... So then, what would happen, it happened a lot, is the kids would write this code, right? They would combine them. I want the drums and the bass, right? Drum and bass, it's a thing, right? So you run the code, and you've got the distorted drums. Where's the arm end break? And where's the guitars? Right, this is an interview question. Yeah, it's a good one, right? Because obviously we're in a single-threaded program. We start at the top, we enter the loop, loops that go forever, right? So the program never, ever gets out of this loop, does it, right? It stays there, stuck there forever. So this code is just sitting there waiting, bored. It's never going to get executed. And I remember that the first time a child did this, she put her hand up and she said, I'm really sorry, I'd like to be able to play the drums at the same time as the bass. And you say, ooh, that's an interesting one. I haven't thought about that. Yeah, you definitely do want to be able to do that. And, oh, yeah, you can't do that with this approach because this is how traditional empirical programming languages work. You know, they work at the top and they work way down, and you've got a loop there which is going forever, so it's just not possible. What you could do is you could, like, manually weave them together like you were knitting. Like, so you could write a program that sort of did one or the other, but that's harder to consider than this. This is much easier to work with 3 separate things and talk about the time between them than it is to sort of knit them and weave them together yourself. Or we could do threads, right? That's going to be easy. So I said to the teacher, hey, can we put threads in for next week? Because the kids really want that. And I can see how they love doing the drums and the bass. And the teacher said, that sounds cool. Is it on the curriculum? I'm like, okay, got functions, it's got data structures, it's got booleans, variables. We did a lesson on variables, actually. It was the worst lesson ever. The kids, they would just write, like, Coca-Cola equals 5. I've got a variable, like, Justin Bieber equals 7. Like, why are we doing this? I don't know, it's on the curriculum. Okay, fine. They didn't understand why they did. So that was a terrible lesson. That didn't work out well. But yeah, it wasn't on the curriculum concurrency, so I said to the teacher, no, it's not, but it'd be fun to add it. She said, sorry, no. No, we can't, because it's not on the curriculum. We can't teach it. We haven't got time. We're not allowed to, really. And so I went to the girl and said to her, I'm terribly sorry. I mean, I didn't say this, actually. I should have done. I wish I had. But you're going to have to wait till you're 18. Because if you're still interested then, you can go to university and they'll teach you threads, right? At that point, when I said to her, I didn't say that, I just said, I'm sorry, we can't do that. It's out of the scope of the project. She just looked out the window and wasn't interested anymore. And I kind of like had destroyed her. Like, how is this even a music program if you can't play the drums at the same time as the bass? This is rubbish, right? And so for them, it was not a real thing anymore. It was not interesting. And I lost that person, and I'm sure that's a tragedy that's going to take a long time to try and fix. So that was, for me, a turning point. How do I fix this problem? So this is the cool thing about being programmers, right? We get to like change the things in ways that are possible. We get to subvert the system. We get to reinvent new rules, you know? And so I then thought about what would be really cool if we could do something like this. Like, let's make a new kind of loop, yeah? Let's give it names. Let's call this Sally, and let's call this one Sarah. And so we give the live loops names, and so they're like band members, right? But I have a band which has one restriction. I can't have 2 Petes, can't have 2 Daves, can't have 2 Sallys. Everyone in the band has to have their own unique name. That's the only restriction. You can have Dave 1 and Dave 2, that's fine. And once you do this, once you move to this approach, you run the code. It's all working in time, right? And that's nice. And so for the kids, they've got their drum and bass. And the teachers are teaching loops. That's on the curriculum. and yeah? Now, at this point, and I had to do a ton of complicated computer science stuff behind this to make sure that, because these aren't just plain, concurrency is not enough, right? Concurrency is already pretty hard, but it's not enough in music. It's not enough for the drummer to play at the same time as the bass player and not care about each other. You're just going to get chaos. They have to be tightly locked together, watching each other, observing each other's tempo, changing, expressing with each other. So they need to not just be concurrent, they need to be synchronized through time. And that's what these threads do as well. So all these threads are I've written my own timing mechanism. I've written academic papers about the timing mechanism, which you can read up if you're interested. And so there's a lot of interest in computer science to make this possible. And it does a few other cool stuff as well, which I'll show you. Before I show you this, the question then really was, this was interesting. The kids who got it, but it was really hard to think about how do I just get everyone who's just doesn't like intrinsically find this interesting. How do I appeal to them? And I think that's a tough question. Because in the UK, certainly, you just go, you are going to learn computer science because you are, right? And you're going to learn functions because it's on the list, right? And you're going to enjoy it. Yeah? And variables, you're not allowed to call them Justin Bieber anymore. We've made a rule about that. It's just got to be called A, B. I think it's hard to find a way to motivate kids to code. And I don't think that's a problem for sports. It's not a problem for music either. Because in sports, there's a ton of professional sports people out there which are really motivational people who are like, I want to be that person. I want to play that sport. And then you'll learn to play the sport. Same for musicians, right? I want to be Jimi Hendrix, right? And now I'm going to learn that weird wooden medallion thing he's got around it. Oh, it's a guitar, cool. I'm going to learn how to play that. I'm not going to pick it up because it's a beautiful object, because I'm intrinsically, some people will, right? The new kinds of guitar makers of the future might, and essentially that's what you are of programs. You'll find intrinsically interesting to pick up programming because it is interesting, right? Super interesting. But if we want to appeal to the people where it isn't intrinsically interesting, which is basically everybody who's not in this room, like everybody, then we need to find ways that motivate them. And I think, as I alluded to before, I don't think being the next Steve Jobs or the next Bill Gates is that, right? I don't think. It is for some. And even more important, and obviously now I'm speaking to not the home crowd, programming for business is not interesting. It's not. It's not, right? Programming is interesting, for sure, and you can find interesting things in programming for business, sure, but programming for business, most of you probably don't program for business because you want to, it's because it pays well, right? It pays really well. I know, because I don't get that money. My wife keeps saying to me, Sam, when are you going to get a proper job? I'm like, well, I like doing this weird... So, it pays well. So I think that, I mean, that's not a bad thing, right, in itself, but I think if we're trying to appeal to everybody else, I think we need to find different approaches. And we don't teach sports in school because everyone's going to be a very well-paid professional sports people. And if that was the case, women wouldn't do any sports at school because they get really crappy paid, right? And so it's clearly not that motivation. You'd learn sports at school because it's a beautiful thing to do for your body, for your mind, and it's a really important thing. And same for music. You don't learn music at school to become a professional musician. You learn it because it's a really beautiful thing for your mind and in collaboration, and working in bands is a beautiful thing. I'll talk about that in a moment as well. And so, my question was, once I got to this point, I got this technical thing that worked, you could teach computer science, that's great. The Raspberry Pi Foundation people are saying, well, you're finished now, Sam, because obviously it works. I'm like, no, there's loads of stuff to do. No, funding pools. So I'm like, no funding at all. Well, what do? Do I go and get a proper job again? Or do I try and keep going? And in my head, I wrote a magazine article. I should have had the clip of it for UK National Magazine. And I described a scene where there was a performer on stage writing code, and it was projected behind them, and that she was changing the code, and the code was changing the music. And this was like a new kind of performance. And obviously, I'm describing a very traditional in the weird artistic computer science music world. There's this whole live coding scene, and this is a very standard thing in those worlds, but most people haven't seen this or heard of it. It was like trying to be like a futuristic scene, and I was designing this as a way to think about what is that next motivational figure for these children to learn how to code. And the cool thing is that she exists, and she's called DJ Dave. Here's her Instagram feed. And the last couple of years, she's done some amazing things. Logitech picked her up and put her on their main adverts. She's performed at big, massive stages around the world, and she's writing code, generating music live on stage, right? And she is the motivational figure, I think, that people are going to aspire to, not Bill Gates. And so this is the person, these people like her are the people I'm writing Sonic Pi for going forwards. And I'm finding ways to make sure that their artistic abilities, their ability to express themselves are maximized. Because when she performs in front of thousands of people in New York, she does, for many of those people, that will be the first real programming they've ever seen. Think about that. Right? Most people haven't seen real programmers. Do you get like loads of people standing behind you going, let me watch your program? It doesn't really happen, does it? And so most people's programming is like they've seen is from the TV. We've seen the TV. We've seen The Matrix. That scene from Jurassic Park with the spinning cubes. That's real programming, isn't it? And so like everyone's perception of programming, I think, is totally warped. They think it's just for business, and they think it's spinning cubes and text falling down and like really fast typing. They don't realize that most people's programming experience is sitting there going, why is it not working, right? And occasionally, yes, and then back to, right? That's everyone's life. So they don't see that. Whereas this, DJ Dave, when she performs, she really is writing the code. She really is evaluating it live. It really is real programming. And she really is a professional programmer. She won't call herself that, probably. She'll say she's a musician. She's a live coding DJ. But she's a professional programmer. She makes her money programming. And I think it's cool. I think we need to be finding more people like this and supporting them, because I think these are the kinds of people who are going to broaden society's perception of what programming really is and break it out of its constraints of being a business-only technology. Yay! Now, that shouldn't surprise you at all, right? Because how long have I got left, by the way? Oh no, I know, I've got loads more stuff to talk about. Sorry, I'm spending time talking about DJ because I think it's amazing. I think there's, I've lost my plot. I've lost the plot. So let's go back to the code. So where am I now? So how am I trying to support this? So I speak to her a lot, and I'm interested in what she's doing. I'm also working with other musicians as well. And one thing that's happening more and more is people are working in sort of bands and co-located spaces, and also I'm really interested in supporting bands which aren't in co-located spaces. It would be really cool if I could jam with somebody from the Netherlands, with somebody from Brazil, someone from an African country, all working together. It would be really cool. So that's kind of the direction I'm going. And also supporting professional musical equipment. So like, there's loads of things which support this thing called MIDI, which is a really simple protocol for sending music events to synthesizers and from synthesizers. Sonic Pi, I don't have a MIDI controller here, but you plug a MIDI controller in, you turn the knobs, and these pink things on the right, this is my visualizer from my internal event database, which is a sort of a tuple space, which is deterministic and totally ordered by time. You can then sort of see those events flow through, and you can then say, wait for the next event which matches this pattern and make a note, or what was the last 4 events from this particular device, if it was this sequence, and do that. Or you can start to program whatever you want with these MIDI events, which is pretty cool. But also weird for a lot of musicians, because they expect when they press the MIDI notes for it to make a sound. And Sonic Pi doesn't make a sound, it just displays the events. But it invites you to tell it what to do when you press that note. And everyone's going to have a different idea, and that's the exciting part. So we already have MIDI in and out. We have multi-channel audio in and out, so I can work with a sound card with multiple speakers or multiple microphones. I can take someone's guitar and someone's microphone and someone's electric violin, bring them all into Sonic Pi, add effects, reverb, distortion, all live-coded, all on the fly, which is a lot of fun as well. Haven't got time to show you that, but I'll show you that as an example later. But the latest thing I'll be working on, which is really fun, is this idea called Ableton Link. So there's this. Let's go Ableton. Good thing about Google is you don't have to type properly. It still works. It's brilliant. So this is technology called Link, and it's really cool. And it's built into. You can't really see what it is there. There we are. So there's a ton of pieces of software, professional DJ software, and production software, and hardware, and iPad apps, and all sorts of iPhone apps. And the idea of Link is every computer or app, essentially, piece of software which has this built in on the network, does like a broadcast, UDP broadcast, discovers each other, also has auto-discovery built in, and then does some resolution and determination to agree on the central tempo for the music and the phase within that tempo, so where you are in the bar. And everyone then has this, on the network, has this one idea of time and BPM. And then you can then all jam together. Super cool. And so I remember seeing this technology come out of Ableton. I sat with the CEO of Ableton and I said, please, can you open source it? And I have no idea if what I said helps or not, but they open sourced it. And that was like sort of 5 years ago. And it's taken me 5 years to get back on my feet to be able to get in the position to build it in. But I built it in a way which is I think is interesting to you guys because everyone there. It's because it's an Erlang NIF now. So I have it baked into the beam. And so the beam now can actually execute programs in time with other beams or other piece of software on the network in time with each other. Which means I can take like a program like this, load example block game. I can not use 130 BPM. I can just use this link thing, and I can run this code. Well, actually, I should link up as well. I've got 0 links down there. You can't see that. But I can also start this Ableton Live software. And this could be another piece of software on someone else's computer. In fact, if you're on the same network and you've got the latest beta of Sonic Pi, you'll be able to do the same. I can click a link on this. Where are we? And it's now linked up. And now I can change the BPM from Ableton Live, right? And speed it up. Which is fun, right? And this is Ableton Live running on the same computer, but this Ableton Live could be running on any computer on the network. And this is a lot of fun to work with. So that was a ton of work to be able to turn a timing system that was built with an explicit understanding of what time was to one where the time. So I can do the music myself. It's okay. and to a system where the time was controlled externally. That's a lot of work to do, but it's in there now, and I'm really excited about that. So we'll be able to work together with bands. So I'm looking forward to being able to give a talk where this software is released, get everyone to open their laptops, and we can have like a massive jam together. It's going to be exquisite, right? So that's there. But whilst I was doing that, inside Sonic Pi, I've been working for a long time, working on the timing systems. And I had this idea. So Sonic Pi uses this supercollider thing and sends it the way it works with timing, because I'm obviously not doing good timings, precise timing from Ruby, or any language with a GC that sort of pauses for any amount of time, because that's just daft. So Ruby's sort of managing what the time should be, and then sending time-stamped events ahead of time to a piece of software which then schedules. It looks at that time and goes, I know what the current time is, I know what the time we want that is, I'm going to sleep for the difference, and then I'm going to schedule that to happen. And does that really accurately. That's what supercollider does really well. So I wanted that for MIDI, and I wanted that for network events. So you can send these network events across, so you can jam with other people and send what the current key is or playing a note. But I didn't have the skills to write this. And I knew it had to be something like in low-level C. And this is when I discovered Erlang, and I was looking at the model of it, and I was like, yeah, that looks like a really nice thing. I could imagine you could like spawn a process and just get it to sleep for that amount of time, then forward it on. And then you can spawn a process for every single event you want to sort of forward on, because you can obviously have millions of processes, super easy. And I remember speaking to Joe Armstrong about this. I bumped into him in a conference. He was like, yes, Sam, that's great. I've been thinking about music things for a long time too. And he was like, oh, about this. I've been thinking about this thing where I'm gonna make a piece of music where I'm gonna schedule every note for like, for exactly when it should be played. So right at the start, I'm gonna play all the notes at the same time, but they're all gonna have different delays. So they'll come in at the right time. And this is exactly the same idea. And so we talked about this for a while. We became really good friends. And he just coded up the scheduler in Erlang for me. And so that was part of Sonic Pi for the last sort of 5 years. And we made really good friends. And we hung out. This is actually us here, actually in this building. We gave a talk together. It's him playing my Moog synthesizer. And his code was played in the Royal Albert Hall. So when I did a performance with these kids in this massive venue, it was brilliant. Joe's code was running inside of here and scheduling all of the synthesizers. That's me and Joe in Stockholm. So he got him on stage. He was busting out the beats, which was a lot of fun. There he is. He always loved fancy gadgets and playing the piano as well. I don't know if this is actually a video, is he? Joe playing the piano. We talked for hours about this, how the piano, how notation could work, and we'd have lots of sketches. We had lots of plans. I was going to go again for what to do, and then unfortunately, obviously, he passed away, which was really unfortunate because I was really looking forward to building some cool stuff with him. But he certainly brought the whole Erlang ideas to Sonic Pi, got it started. We worked with a version of the Beam, which he used some e-scripts to generate, which sort of cut down all the bits I wasn't using and made a sort of minified version, which we'd been using for a while. But obviously, the support line went away. I couldn't, hello, Joe, is not answering anymore. So I needed to think about how I was going to go forwards. And clearly, the Erlang thing was growing and growing and growing, and that was clearly the way forwards. For all the Ruby stuff I was using, I'd written my own sort of crappy version of supervision trees to do the threading stuff. Lots of that stuff is going to be really easy to get into the Beam. And I've been aware of the Elixir community for a while. You seem like cool people, right? But I avoided you all for a while. Because I remember when I learned Clojure, I was really annoyed that I didn't spend the time I should have done to learn Java properly. Because I was like, I'm going to move on from Java. I don't need to do Java. No, I'm going to do Clojure. It's way cooler. But obviously, when something goes wrong, Java spits out at you, right? And like, what does this mean? Oh, I'm not going to learn that, so I'm going to learn Clojure. And so I really regretted that, because if I'd have learned Java first properly, I think my Clojure experience would have been much better. And I've understood it much more. And so I was like, I'm going to learn this Elixir thing, but I'm not going to learn it. I'm going to learn Erlang first. And actually, it was a really good idea. I recommend it. If you haven't spent any time with Erlang, totally do it. Because then a lot of the Elixir semantics just made a lot of sense. It's like Ruby sort of like look and feel, but as soon as you look beyond it, it's totally different. It's really Erlang. And like lots of Clojure ideas as well seem to be in there. Like the idioms seem to be very similar. And so that was really a sensible thing for me to do. So in the last sort of year, I've been working really hard to bake in Elixir into Sonic Pi. So now we don't use Joe's old scripts anymore. We use mix release to generate the internal Erlang Elixir distribution. It boots into Elixir first, and Elixir then spawns all the Erlang stuff. And calling Erlang from Elixir is really, really a beautiful thing. So that was a really nice thing to do. And then I was thinking about where to go forward. So as I'm starting to move more and port more of the ideas from this Ruby syntax across onto the Beam, it makes complete sense to think about how we might start building new interfaces to this. And so it made sense to think about how do I do something like this, where maybe I've got LiveView built in to the app itself. This is running live on the. I don't have an external process that's running separately. This is all inside Sonic Pi. Sonic Pi has a GUI, it has a browser baked in, has the Beam baked in, has LiveView baked in. It talks over the local loopback network to send these things. So this doesn't suffer from the issues of having it on the server on the cloud. The server is on the same node. And I could also go across into my weird Emacs environment and see if I can find, where are we? Where is that code? It's you can't read this. I don't expect you to read this. Developments, Sonic Pi, app, server, Beam, Tau, lib, Tau web. Now, I always forget the names. I forget the difference between views and templates. They sound the same to me all the time. So which is the live view? Is it templates? No. Page? No. Is it live? I need to remember these things. Live. Yeah, it's the rainbow one, right? So here we are. And I can then change the deep pink background to black, like this, and save it. And now I've got black background. It automatically updates it live. So all that stuff, right, is all working now. And I've put a lot of effort into trying my best to guess what you might expect, right, to be a normal kind of Elixir environment. And there's a ton of more work to do in this, but it's there. All the technology's there. Now, it's not there. When you download the new version, you won't see this. It's under the scenes, hidden away. But I am going to work on it more and more. And when it's really ready for people to use, I'm going to start building new GUI parts and things inside LiveView. I'm also going to work to try and move much of the language across to Elixir as possible and build my own new language on top of that, which is network safe. Because I want to be able to start sending code back and forth between machines and not worrying about someone sending me a shell script which is going to delete my hard drive. Which is kind of a problem, especially in schools, right? Because kids will do that. They will. So there's a whole ton of... really what I'm here to say is that Sonic Pi is fun. You should learn to play with it. I've tried to discuss the motivations for it a little bit. I haven't really gone into any detail about how the technology works or what you can do with it. But I am going to do a demonstration, if I can get my stuff set up shortly afterwards, where I can show you what kind of things you can do with it as a performance. I really would like you to play with it for two reasons. Right? One is to find a way to talk to all of your friends and family. You've all got friends and family, right? That don't program. And to be able to have a conversation with them. Because, I mean, how many of you have been to a party where you've said to people, "Hi, I'm a programmer"? Oh, that's killed the conversation. Oh, okay. So now I lie, right? I now say I'm a musician. Right, that's cool. Right? And they say, "Cool, what do you play? Guitar? What? Code, right?" So, and at least then the conversation started. And I'm able to talk to people about programming and what it is, not just as a tool for making money, but as a tool for human expression, right? And that's exciting, and that's what people enjoy talking about at parties. Well, so I guess some people love to talk about making money, but they are not the parties I typically go to. And so I think that's... just for that reason, I think it's interesting to look at tools like Sonic Pi because it allows you to participate with a broader community about programming. And I think that's a really important thing to do. I think it's important to try and broaden society's perception of what programming can be, as I said before. What was the other thing I was going to say? I've completely forgotten it, but it's gone. Yeah, that's gone. What was I talking about? Code, music. So there we go. So that's and I want. There's a second thing I want you to reason. One is obviously social events and understanding and teaching kids how to code and just getting more people aware of what programming is. But the other thing is, this really I'm hoping is going to be a playground for you. I'd love to be in a position where I can throw this at you and you can start building your own interfaces for music, your own little DSLs, your own little GUIs and widgets and all sorts of fun stuff, which then control and drive all the cool audio stuff that I've already built. And I think that's the real opportunity going forwards, is to think about this is obviously not going to be an Elixir LiveView example demo, right? What would this work? What's a replacement of this, which is really deeply interesting for everybody making music? And I think there's an exciting opportunity for maybe a future talk where someone stands up stage and says, Sam laid down this challenge, and I've changed the rainbow wavy thing to, what will it be? So I'm really hoping that some of you might be interested enough to join me, to get involved, start hacking on some cool stuff, and building kind of the musical interface for the future that will support people like, where are we again, DJ Dave. And then she can then inspire that next generation of programmers that will see programming fundamentally differently and for the better, in my opinion, than we currently do today. Thank you very much.
Thank you, Sam. That was truly inspirational.
I can also say, I also need to say that this last year I had really issues with finances, and it was the beginning of the year, I was zero in the bank, and Jose and Dashbit stepped up, and they've given me 6 months of part-time sponsorship, so I'm really, really grateful for that. So thank you very much, Jose and Dashbit.
It's also worth mentioning that the code is up on GitHub, is it not?
Yeah.
So, you guys can download the code and play with it, but you can actually download and start contributing if you feel, motivated to help Sam on his journey with Elixir. So.
Any questions?
Do we want to have questions? I guess there's someone over there with their hand.
Where do we go to support you?
Where do you go to support me? Well, the way to support me is to spread the word. That's the best way to support me, because that's really the mission I've got, is to try and share what I'm saying to you now with as many people as possible. So that's really the best way to support me. But obviously, if I run out of money, then I can't carry on working on the software. And so if you've got a spare bit of money for a cup of coffee, then Patreon's a good place to support me. And so you can just Google Sam Aaron on Patreon. Also, I have a GitHub sponsors thing as well, which works really well. Or if you're a company that wants to sponsor me, I'm really happy to talk about what ways we can make that possible. That'd be really cool. Because someone mentioned on Twitter the other day that it apparently costs $15,000 for a new recruiter to pay for a person to come in, and Sonic Pi is like engaging a whole new generation of people, and so if you can give me that $15,000, right, I'll give you 10 new programmers, right? Any more questions?
Yeah, so I used to work with a company called Code Club, or a volunteering organisation called Code Club.
Code Club's cool, yeah.
And I wondered if you'd had anything to do with them, or if any of this stuff has been gotten through them, just as like a means of outreaching to schools.
So yeah, I mean, I originally did work with the Raspberry Pi Foundation, which then, of course, bought Code Club. Whether that's a good thing or not is to be considered. But they were running out of money, weren't they, at the time? So the problem with the UK and charities is that we have a great way of getting charities started, giving them a ton of money to do some cool stuff, and then when that budget runs out, they're kind of lurched, and that's where the Raspberry Pi Foundation stepped in. So at that point, my relationship with the Raspberry Pi Foundation was getting a bit unfortunate. I don't think necessarily they were, I'm being careful with my words, in line with my philosophy. At least it didn't resonate with them as much as it resonated, perhaps clearly has with you. And Code Club was just coming into the foundation at the point where that was happening. So I didn't really do much. There are Code Club worksheets for Sonic Pi. They exist, but not really. I was definitely involved much more heavily with the foundation, Raspberry Pi Foundation, before Code Club merged in. And I was doing a whole ton of stuff, going into schools and having a lot of fun, and teaching, doing the Pi Academies. So the Raspberry Pi Foundation did a whole bunch of teacher training courses all over the country. And so I was teaching Sonic Pi as part of that for a long time as well. So I've definitely done a ton of work in schools with charities like the Raspberry Pi Foundation, almost Code Club, but not quite, and other organisations too. And so yeah, that's been a lot of fun. But now that seems like a fairly solved problem, as long as it's easy to install on Windows computers, which is the elephant in the room, and for schools. The really interesting thing for me is to find out ways to drive that engagement. So that's why I think working with musicians in a way that makes sure that all the new ideas that are going to be interesting to musicians also fit the design philosophy for schools, which means that no feature goes into Sonic Pi unless I can teach it to a 10-year-old child. Like Sonic Pi is like a distributed, concurrent, deterministic, time-based environment, and all of those things, all of them, 10-year-old kids can understand. So that's also wider, one thing to take away from this is that you might think you've got a really complicated system, right? And so you can't make it any simpler. But I've got a pretty complicated system, and I can teach it to 10-year-old kids. The only thing that I've done, really, is spent a ton of time distilling all the ideas into things which are simple enough. And that takes a lot of effort and energy. And I guess that businesses don't typically value that. And I do. And when you have put that effort in, it reaps the rewards really, really quickly. Yeah.
Yeah, I also had a small question. I've also used Scratch to teach children programming, but it's block-based. So have you also ever explored using a block-based interface to do
So
this?
good question. So, so the things like Scratch are block-based, so like drag jigsaw pieces around. So I think that it might be cool to have a block-based thing there, right? Who wants to work on that? Seriously, right? I think that supporting new kinds of syntaxes, new kinds of ways to work with the code is really, this is where this place is like an experimental playground. So I'd love to see, I've thought about it a lot, but it's like, I'm only one person. And most of my energy is finding funding, giving talks, trying to get people excited, as well as trying to do the coding, as well as supporting all the users. It's a ton of time. So I've got to be really careful with what I do. But I'm super happy to work with people who want to work. If you want to work on that, let's do it. It'd be cool. Yeah, question?
Thanks for the walk. If you would want to do something like sonification of, let's say, log data or something, would this be possible right now? Is this like super complicated? Would you do like a log to MIDI converter?
So what was the question? So if I wanted to make logs?
If you want to like do sonification.
Sonification
of like log files.
Oh, right. So Sonic Pi is able to receive network events with a format called Open Sound Control. So you could write an Erlang program or an Elixir program or a Python program that spits out these events, and Sonic Pi could read them in and then turn them to sound. That's dead easy to do, yeah, so totally.
Dope.
Yeah. And going back to the point earlier about like recruiters costing $15,000, I got this message from LinkedIn the other day, and I asked Orbin if I could share this with you, and he said yes. And he wrote, 5 years ago, I started coding in Sonic Pi to build a smart music box. A musician who couldn't code but kept at it. Projects got bigger and I learned so much I climbed out of a crap hand I was dealt in life and recently got a job as an ML engineer. Just wanted to know you changed my life. Thank you. And I get this quite a lot. This is amazing, isn't it? And obviously for every one of these, there's like 10 other people who haven't sent me a message. And so this really is the world I'm trying to create. And I really am trying to do this. So I really, really value your interest and your participation in helping me do this.
Hello.
Hello.
Do you need to know much music theory, do you think?
I'm sorry, I didn't quite understand that.
Sorry, do you need to know much music theory?
That's a very good question. Do you need to know much music theory? No. I think that was one of the goals, actually, was to make sure that, because any of these things, like also speaking to music teachers was really tough as well, because they are very gatekeepery about what music is and what music isn't, and I was very frustrating all the time. But really, if you know music, some Western music theory, it's like, what is music theory? So it's like, if I'm going to design a website, I might go to designer and they might give me a color palette, right, using some color theory. And Western music ideas are really just like some constraints over the infinite space of tones and styles and timings you could use that resonate well with the Western cultures that we've sort of all quite like a bit. The only thing musically, I think, that's similar across all cultures is the idea of an octave, where you take a frequency and you double it or half it, and you get a note which sounds the same. That's one thing that all cultures seem to agree on, that sounds good. But beyond that, there's no real agreement. And so the idea of music theory is really, it's very constrained to whichever context you're considering it from. Like music theory in the Western world is very different from the Eastern world. But even then, knowing some of that music theory can help you. but it can also be a massive constraint. I remember meeting a few different musicians, actually, who said the same thing, which is, I wish I could unlearn my music theory, because it's kind of blocking me from being creative, because I can only work within its constraints, within its boundaries, like do correct music, to the music theory. So actually, I'm more interested in breaking out of music theory. I'm more interested in people making music that's atonal, that's weird timings. In Sonic Pi, there's no BPM, although I just showed you that weird link thing, which is a global BPM, which is shared over the network. You don't have to use that. It's not on by default. Each thread can have its own BPM, its own tempo, its own idea of what it's doing, and so they can be independent, and then you can bring them together and you can take them apart. You can work with music that doesn't fit into the 4x4 dance music style. You can have the different threads slightly out of time with each other and coming back into time with each other. You can program all this kind of stuff. You can work with notes which are between notes that aren't on a piano, but you could access with a guitar if you bend it. All those things are available, and more importantly, all those things are as easy to do as the Western music theory ideas. And so I really want people just to experiment and play and find stuff they like. And if then that drives them to spend more time looking at Western theory or whatever theory they want to, great. But just to get started, not at all. Like, you can, my battery's about to die, so at some point it's going to go. You can play E4, like E5, play E octave 5. If that means something to you, cool, right? Also, you can do this. Like, type people are going to shout at me for that, but take it a bit higher, right? What does this mean? Adding a number to a symbol? What's going on? But actually, you can just use numbers, right? And so I can just use 70.3, whatever, right? So I can play with all the... So if you don't like that note, well, is it too high or too low? Just choose a higher number or lower number. Don't care what it means, and just keep playing with it. And you'll find some stuff randomly you like, and that's a critical thing to be able to do. So you can use Western theory, but it's definitely not a prerequisite at all. In the same way, to learn Sonic Pi, you don't need to be a programmer. Like, again, that would be a huge barrier. Or you don't need to have expensive computers. It runs on a Raspberry Pi, so it's £25, you can get started straight away. Or a really old PC, get started straight away. So yeah, so it's trying to lower the barrier to entry for a creative experience with code. It's like one of the missions we've got. Yeah, any more questions? Cool. Oh yeah, one at the back. Hello. You got to run. Da, 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 da.
So if I have kids and I want to get them started on this, is the course, the material that you talked about, available?
Yeah, so I showed you this weird tower thing, but there's documentation built in, right? So there's a full tutorial built into the app. It's also available on the website. It's translated to many languages already. We're crowdsourcing the translation efforts. So it's possible, if you're not a native English speaker, we already have a tutorial or large part of it translated to your language. If not, and that's something you want to get involved with, you can just translate one sentence at a time. It's a cool website to go to do that. So yeah, we have a full tutorial. There's tons of also resources online as well. People have made some really interesting courses, YouTube videos, and all the things to get you started. So there's a ton of resources available. And there's always going to be more. Once version 4 is out, I can start working on the cool Elixir stuff I was talking about, and I'm also going to work on a video series to try and... Because kids don't want to read, do they? They don't want to read tutorials. They want to watch TikToks. So I need to learn TikToks. So you can call it TikToks, do you? But I'm going to do that. Yeah, I'm old, so I'm going to call it TikToks. Yeah. Any more questions?
Okay, thanks very
Cool.
much, Sam.
Thank you.
Round of applause.